So let's look greater in detail about what happens in real amplifiers that are made of transistors due to the non-linearities that arise due to the saturation and cutoff in transistors that are made used in the amplifiers. So these non-linearities arise due to the saturation and cutoff of the transistors that are used inside. So ideally we would want the output to be a factor of the input. We say that is an ideal linear gain, beta being the ideal linear gain, but in reality, due to the saturation in transistors and cutoff, essentially the output is going to be not just a linear relationship with the input, but also a quadratic and cubic and higher order polynomials in as such. So this is a non-linear relationship where this is the linear term, this is the quadratic term, this is the cubic term, and so on. Of course, it all depends on beta 1, beta 2, and beta 3, the weighing factors for each of those terms. But beta 2 in general is not necessarily equal to 0, and beta 3 is not equal to 0, which leads to the output non-linearly depending on the input V1, Vin. For example, if you take a single amplifier, a single transistor amplifier made of a field effect transistor FET in this case, the output voltage for this configuration is going to depend on the Vin, but the device is going to act like a square law device. The transistor is going to behave like a square law device where the output is going to be dependent on the input voltage in this fashion. So we see that the drain current is going to have a quadratic relationship to the input voltage. If it were to be a linear device, then you would expect just a linear curve, whereas since it's a square law device, it is having a quadratic relationship, and it is said to have second order non-linearities. Second order because the power here is 2. Another configuration is what is called as a differential pair. A differential pair is a common amplifier configuration where the input is fed across the two transistors rather than just one here, and the output is across the two FETs, across the two drains of the FET transistors. So if you see the output characteristics, the voltage output across the two drain terminals compared to the input voltage, the relationship is going to look like a curve here, which is an odd function in and it is said to have third order non-linearities. So a single transistor is having second order non-linearities, and a differential pair exhibits third order non-linearities. If the amplifier was a linear device, an ideal linear device, then the input-output relationship would be a straight line, perfect straight line, whereas in this case this is going to be a third order non-linearity exhibited by the differential pair. Now these non-linearities are going to lead to several consequences when amplifiers are used, and what three main consequences that we are going to look at is called as harmonic distortion, gain compression, and intermodulation product. We will see what each one of them is in greater detail.